things, kidney failure, and stuff. But safety is fine. They try to disconnect the element of infection change. And living agent, agent is a physical, biological, or chemical entity that causes a certain effect upon exposure. It's called agent. Host, the habitats of agent, I think usually humans, animals, any kinds of that can live in the virus or any bacteria can live with the host as a to propagate. Environment comprise living and non-living include a biosphere, atmosphere, lithosphere, and hydrosphere. Okay, this is the interaction between agent, host, and environment. So they have three things here. I think one is agent, one is host, or the one is environment. I think agents is I think well known is including vector, carrier, replacement of vector, antibiotic resistant. So some of you might doing some what strain screening at the lab. Probably they will do bioantibiotics resistant, viral factors, infected factor, and death factors. And they have a health status. Usually, host usually human, like say human, animal, any small animal, bird, or this kind of thing. So you listen some of the influenza, especially the flus, come from the bird. Okay, training, health monitoring, use of PPE, perception and retention, environment, include the population, medical support service, weather, social and design also facility. Okay, factor that onset the disease pathogen. I think this is a few factors that really contribute to the onset of the disease. Pathogen agent, I think this is a pathogen. Depends. Let's say like Ebola or this kind of thing. Ebola is really Africa. I think this deadly disease. I think within maybe a week, I think you probably die of it. And existing of a reservoir. I think this is whether the bird or the chickens or anything, pork, pig or this kind of thing can be a reservoir for any kind of disease. Agent capable of retention and agent mobility. Agent mobility sometimes this is seen to the bird. The bird have migration season. They will migrate to certain from the north to the south hemisphere, and certainly with very different kind of disease also. And entry in a new host and how it's gonna affect the new host and subsequent host is whether it's humans or this is quite common. Okay, this is an infection chain. I think this is more important. Whether it's they have a different type of change. I think this is why you need to know about the change, because certain termination or certain not you cut off one of the change, probably the whole thing gonna not gonna work, actually not gonna have a the disease not gonna spare out. That's why during COVID-19 I think we have the isolation. That's why ask the people who have infected, they will go for isolations. Okay, characteristics of biological agent, no threshold release. That's why I mentioned now, I say biological weapons or bio agent become more targeted. I think they pay more concern about this one, because you can carry a vial of virus inside your bag, okay, without a detection. You just go and screen, nobody will know what is it. You just carry a small, don't carry a big bottle, just carry a one vial for something. You just can bring back to Iran, Iraq, or this kind of thing. Nobody know. Nobody's know about it. As long as you don't carry more than 100 ml, this kind of thing, then nobody will know what's. So sometimes it's very dangerous of setting. Can exist in any environments where there's this kind of sabotage. I think you heard before, maybe that they want to sabotage other water resources, anything. Actually, using a biological weapon can be a very dangerous part. Okay, infected and influenced by biological competition. Okay, something is characteristics of value. So biosafety cabinet, I think you notice also informed they have a biosafety cabinet level 2. I think you have a level 1. I think level 1 is common one, is not known to cause disease usually, a normal biological practical. I think this is a common one. I think level 2 is the one we use in inform, able to cause a disease in human. So that's why we need to use biosafety level 2. or 1 ml of this kind of biological can kill 1,000 people. So it's more dangerous compared to chemical weapons release, and be found in any environment and influenced by biological condition. Okay. Okay, infection control is succeed by breaking one of the link or more on the links. That's why the infection, if you got 6 infection change there, and you maybe stop on one of it, like 1 or 2 lah, maybe. Then after that, you probably can stop the infection change. There are 4 levels of biological applicable with different potential risks. That's why you need to identify, okay, which type of chemical biological weapon you're working with, and maybe suitable, maybe in inform. We have a biosafety level 2. I think we don't have a biosafety level 3. That's why we cannot work with HIV or TB, because that we need a biosafety level 2. Okay. Safety while working biological agent is most important to ensure there are no severe risk of infection. That's why usually in the I think level 2, I think we wear a mask with glove, double glove, proper lab coat or this kind of thing with a goggle. I think in level 3 actually, usually you have to wear a suit or this kind of thing. You have the proper suit, and sometimes not really we don't have a individual respiration system. You just wear your proper way. I think you need to certain type of training of this kind of thing. It's not something easy. Okay, finish biological weapons. Where we go for occupational standard. This is a occupational health standard. What it means like this? This is something else. This topic is more the standard. Okay, I think in Malaysia they have their own standard. They have a book for this. Different country, I think, if they own your standard, because please refer to your own country standard, because different country have different type of standards. So make sure that you refer. Don't take, let's say you learn from Malaysia, then you use the standard. But usually, I think most of the time the threshold is universal. Sometimes you see universal. So Malaysia also don't let by cert. I mean, they take it from UK, from Australia, from US. Okay, define our health standard. Category of threshold limit, TLV, as limitation of healthcare standard. Okay, this is the scope. Introduction of protection. So why this is why they need to introduce a threshold limit. Threshold limit is mean the limit, what the maximum, I think the maximum level, understand, okay? And sources of reference, and then usually they have to, why this have introduced a threshold limit, and what's the reference? Because you cannot simply say, this is 1000 ppm, okay? You just cannot simply say that what? From where you get the value of 1, because usually this threshold limit usually based on the experimental, maybe based on any incident or accident happened before. So they will cause usually a reference of historical checklist, then they make a threshold limit. So this is not something that you simply can come out and decide what you want. So they have a, that's why when come to this kind of safety, everything must have a facts. Okay, you cannot simply I heard my friend said this. No, it's nothing like this. Everything must come from the book. I think any come from book, maybe proper reference. I mean, okay. Type of worker exposure standard, A standard. I think this is most common. A standard. What we have a A here. Biological limits. I think physical agent standard also. Okay, standard type of standard, 2 type of standard, voluntary standard, American Conference of Government, ACGIH, threshold limit value, TLV, the compulsory standard, permissible exposure limit, PEL. I think this is what you will get it after this. There's certain level, okay, why? Because this is what I say PEL, or this TLV, or TLV, understand? This is the law, so this is, I think, it's inside the law actually. Every book or everything, they will give a limit. So you have to follow the law. Even you cannot more than this limits. If not, a violation of the law, you probably can sue with the court. Okay, definition, permissible limit is a ceiling limit or 8-hour time when the average airborne concentration maximum. So this is, I think, 8 hours is a very common, I think, rules I think apply here. So I think 8 hours consider a working hour. 8 hours, you cannot expose all this within 8 hours. This is how the calculate the thing. Because they need a definition. They cannot simply 1 day or 24 hours. They need a definition. I mean, you should add hours. So why? Threshold limit, airborne concentration are sustained when they are multiple by exposure of majority of the water without effort, avoid the human effects. I think this is threshold airborne. I think usually I think in form usually we don't really have an issue with airborne. Because usually we have an issue with airborne usually in the mining area where they have air pollution or this kind of thing, where I think we have a lot of dust or this kind of thing. I think in the furniture, we do a furniture, right? Then you cut all the wood or this kind of thing, they have a lot of dust or this kind of thing. So this will affect your thing. And in the cement, that they have to do analysis. We cannot just spot one place. They have a different space also. I saw people do it before. You have to show a different face. I say one lab, I think maybe they put a fuse collection sample, the equipment just to collect the air quality to get a standardized. Okay, different attend sample and reflect accuracy of the breathing zone sample for sanity also. Uncertainty actual quantity in here. Sometimes it's different. You measure all the quantity different corner. Let's say this room there are 4 corners. You measure the lab, but actually you breathe in. Actually, you have to the difference here. Different air is your 4 corner of the this room, but when you breathe in, actually you throw your small space only a small space. So sometimes very difficult to check the quality whether it truly reflects what the air quality that you develop or sales. So one thing is carcinogenic, I think. I think this is something you need to know also. Confirm carcinogenic, suspect carcinogenic, proven or animal, no clarification or no science. I think some of you might working with the ethylene bromide. I think bromide one of the carcinogenic also. So be careful actually. Then you ask why we have a this kind of carcinogenic agent in the lab? Okay, actually they have other replacement. They have a cyber green. Okay, they're saying they have a cyber green for staining because adenine bromide is not just for staining. And why adenine bromide is still retained? Okay, we done a study before. The cost of the using other agent like cyber green actually is far more expensive. And this is adenine bromide is cheap, very cheap. I have to say very cheap because we only need a 1 2 drop actually, and it's a very good agent. I think you can see the staining DNA is really and with the again bromide also the proper way you use charcoal in the our lab also they use charcoal to activate the again bromide so it's no problem as long as you follow because some people why because they cannot follow the proper protocol they learn it before I think you learn also the lab training also it show you how to do the throw the within the bromide or this kind of thing but sometimes you just ignore it you just throw the thing into the sink. Inside the sink, after that, they will release to the water system. Maybe go to river or the thing. Then end up actually contaminate the whole things. Maybe contaminate the fish, maybe other plant or this kind of thing. So careful. I think lithium bromide, yes, it's dangerous, but one thing it cost effective also. I think we have a good control system also. The proper you use charcoal to activate it, everything's your proper storage. After that, we request a company to a proper company. I mean, we don't sometimes
It is.